standard components, that's probably a huge one. In SolidWorks, the main thing to understand here, I guess, would be reuse of common files, right? So hopefully a number of you use the design library to some extent. Basically, the design library tab here allows you to customize different libraries. So if you're a machine designer, I don't know that I've met a machine designer that isn't purchasing standard components and wants to include them in their assemblies. So you can build different libraries accordingly. You can have as many of these as you'd like. If you're not familiar with how to add these into SolidWorks, it's pretty simple. You're basically going to your options in SolidWorks, file locations, and then just point this here to design library. And you can add in as many file paths as you'd like. And that's how many design library directories will show up in the task pane over on the right. So you notice I had 4 of them listed. That's because I have 4 file paths in my system options here. Okay. Again, obviously, if you're in a multi-user environment, these are probably a network location or a shared location, which is perfectly acceptable and recommended. Obviously, those of you that have professional or premium SolidWorks can be using the toolbox. I'm not going to cover that in detail here today. But one thing I do want to mention here is 3D Content Central. Basically, 3D Content Central here is the online repository of standard components. So I don't know if you guys have ever used this site before. I'll pull it up here real quick. In this case, I was logged in earlier. Up here. All right, I should have had that queued up. Oh, my session timed out. We'll do it the hard way. Basically, though, 3D Content Central is really just an online repository that you can search out common components that you use. If you haven't used this tool, for instance, if I wanted to look up that Winsmith that's already in my assembly gearbox as an example, I could do a quick search. You know, basically, I'm getting all the Winsmith products listed right here on the site. Totally free for you to use. You're going to have to create a login and a password, like you have to do with pretty much anything nowadays. You know, but if I go and select one of these guys, I can kind of configure it to what I need here, and I'll be able to download the native SolidWorks file directly for free. So you can actually build up your library using the 3D Content Central tool. So again, you can hit the link right out of your SolidWorks, or you can just go to 3dcontentcentral.com. Again, definitely use this tool. You can even download files in formats other than SolidWorks if you use more than one CAD tool in your organization. All right. As far as some standard components, though, let's just flip this here to a different display state. So let's say I want to go and pop the motor on here as an example. You know, so I just saved a library of components. Here's my motor part that I've saved, and it's going to be a simple drag and drop operation, right? So as I drag and drop this into my assembly, you can see that when I get my motor close to the gearbox, it automatically mated into position. This is fully mated part. Literally all I did was a drag and drop procedure here. And really all I'm using is what's called a mate reference at the assembly level, or part level, really. And if I open this component up real quick, if you're not familiar with mate references, here's your education. But basically here inside of SolidWorks, you can build different mate references, and it's just like a smart mate that it's looking for. So when I drag it in the assembly, it's trying to go concentric or coincident or both, as an example. And that's what you can do here. Now, a little known secret of mate references is if you have a lot of components that you're going to be snapping together all the time, so let's say I use these gearboxes all the time and I use these motors all the time, what I can do is I can build common mate references in both components, and that's basically how I was able to just drag it close to the gearbox and it knew exactly what to do. So if I show you a little example here, I kind of made up a little dummy example here of this. Should have had this open in ahead of time, but you know, let's say here I got this little assembly here, okay, basically with the same gearbox, all right. And inside this little gearbox, I have a mate reference called motor. I've named it motor. If I take a look, basically it's looking for a face, this face in blue right here, to go concentric to. It's looking for this pink face to go coincident to. And it's actually looking for one of the bolt hole faces to go concentric to. So basically it's looking to add 3 different mates, you know, to some other component. So if I go and open a motor, let's say I got this motor here, and I want to build a common mate reference in this component. Again, if you've never done this before, basically you're just going to reference geometry and saying a mate reference, okay? And again, I'm going to match the exact same 3 that were in that gearbox. So for instance, if I pick this face here and say concentric, and I'm going to pick this face here and say coincident, and I'm going to set that as an anti-aligned mate. And then I'm going to select maybe this face here and say concentric. Now I'm going to show you 2 things. First, I'm going to leave the name of this mate reference just as default and hit OK. All right, and I'll save it. And let's tab back over to the assembly and show it in action. All right, so let's just go here to open in SolidWorks stuff here. So here's my motor, right, that I just added the mate reference to. Okay, so if I drag it into my assembly, what I actually have to do here is get my cursor close to that same location for it to try to pick up on that mate. Okay, so I had to kind of get it close in this area for it to pick up on that mate, and then it does go ahead and go and mates into position. It's fully mated in position. It's not a big deal. But watch what happens here. If I hit undo, and let's go back to the motor here real quick. And all I'm going to do is I'm going to change the name of this mate reference to be motor, which is the name of the mate reference in the gearbox. That simple change, basically that mate reference that now has the exact same name, okay, the name is what's important here. When I go back into my item and drag and drop it into the assembly, watch the difference here between the 2. Notice I'm not anywhere close to the gearbox right now with my cursor, and it's trying to mate. I mean, it is mating, it's not trying. It's mating it to the gearbox. And I can let go out here, and it's fully mated. Okay? So by having a mate reference in both components that has the same name, SolidWorks, you can start snapping these suckers really together quickly. And you machine designers, you know, a lot of times you have a lot of components that are common you use often, and you can have that built into your parts and sub-assemblies and so on and so forth. If you take a look here, just to show you that I'm not doing something magical here, there's the 3 mates that are actually added to the assembly in this case. Okay, so if you kind of grasp what's going on here, in SolidWorks we allow you to have multiple mate references, so I could actually apply the same 3 choices in the motor and just name it something different. You know, motor to gear, you know, motor to bracket. So based on what component I'm dragging it over top of, it just knows how to mate to that particular component. So parts can have multiple mate references, like this gearbox actually has 3 mate references in it. They're not all for the motor area. One's for something that would mount to the shaft, the motor, and the base plate. So you could have multiple mate references in the same part file. So that's just a little tidbit there about make references inside of SolidWorks that a lot of people sometimes don't understand or really realize you can do. Maybe we'll try here. If anyone has a question here, I'll open the phones up.
Question for you.
If someone, yeah, go ahead.
If you have multiple screws that are going in to hold that motor on, would you use just a plain screw, or would it be, how would you put in a screw so that you only put in one and all of them would be populated?
So you're saying you need to obviously put the 4 screws in here at this point?
Correct.
Okay. It's almost like I queued you up to ask that question, which I didn't. But that's kind of the next level, is where you would actually use now a functionality called smart components. And we're going to talk about those a little bit later. But this motor I use is actually a smart component to do exactly what you asked, basically. And you'll understand this a little bit more. I'll kind of save that thunder here for 15 minutes from now, maybe.
If you're going into it, I'll wait for the answer then.
Yeah, well, I'll just show you right now on this one how
Okay.
quickly it is. Basically, I can queue up the smart component for this motor. In this case, it's really just going to add the 4 screws in this case. So I basically hit initiate smart component, hit the green check mark, I'm done. There's my 4 screws. So you'll understand how that's working here in a minute when I explain it in a little bit more detail. But basically, it's a smart component. Okay. Other questions quickly here? Why we have the phones unmuted? Okay.
I have a question.
Yeah.
Yeah, go ahead, quick.
Okay, if there was more than one reducer in that assembly and you inserted that motor, what would happen? You know, with your major.
Oh, more than one of these? Oh,
yeah.
I got you.
Speed reducer.
It would function a little different. It would basically wait until you hovered over that particular gearbox.
Okay, so you could put.
Like if I had 4 of these gearboxes lined up, it wouldn't know which one to mate to, obviously. So I would just basically have to get my cursor over top of the gearbox, so I wouldn't have to really get it precisely in the right position.
Okay, thanks.
Is there another question?
Yeah, with display states, you said that they can be used without configurations. You can just make things show up. Do they have to? When do you link display states? That option it says link.
Right, there is an option at the bottom to link display states to configuration. So basically, the only difference is this: if I don't have this option checked on, I can have 20 different configurations, but all of the display states I've created are available in all of those configurations. Okay, but if I'm creating a particular display state and I only want it to be available in a particular configuration, that makes sense. Then you would link the display states to the config.
Oh, okay.
So, for instance, if I turn this option on and had created my test display state while active in this config, then I switch to a different configuration, I wouldn't be able to get to my test display state because it's not linked to that config.
And then in drawings, if you use your display states, that in a sense could be faster than like bringing in, say, a default and then hiding components. Is that faster, or
right? Instead of hiding
memory
components individually on the drawing, yeah, it would be. It should be faster, yeah.
Would it be less memory also? Take less space, I guess. File.
It would only really be less memory. It might be a little less just because the display information isn't there, but it's really only going to be less memory if you choose not to load the hidden components into RAM.
Oh, okay.
Okay. Because by default, hidden components are loaded in RAM. Okay, but you have the option in SolidWorks nowadays to purge that. You can even do it on the fly if you didn't know that. Like I could right-click on the assembly tree right here and say unload hidden components, and that would purge the hidden information from RAM.
Oh, I never paid attention to that before. Okay.
All right. I'm going to turn you off, everyone off here again, and we'll continue, and we'll open the phones back up here in a sec.